topic angular momentum. Angular momentum. So the angular momentum in rotational motion is equal to linear momentum in translational motion. Okay students, so what is the angular momentum? The angular momentum in rotational motion is equal to linear momentum in translational motion. But wrongly we understood that the angular momentum is only for the rotational motion. Angular momentum is only for the rotational motion. It is not correct statement. But wrongly we understood that the angular momentum is only for the rotational motion. Okay students, it is not correct. The angular momentum, it is also having for the translational motion, but for the understanding purpose, here the angular momentum in rotational motion is equal to the linear momentum in translational motion. Okay, at the end of this question, I am going to explain the explanation for the angular momentum. It is not only for the rotational motion. Here the angular momentum is also present in the translational motion. Okay students, right. So first we are going to calculate the angular momentum. From the angular momentum I am going to explain that concept. Right. So for calculating the angular momentum we consider one of the point mass. That point mass is m and it has a linear momentum is p. Okay, the mass is m, it has a linear momentum is p vector. Okay, so it has a linear momentum means what is the meaning? It has a velocity is v. So by using these values of mass and velocity we can calculate the linear momentum. That is not a vector, p vector. P vector is equal to m into v. Okay, so in other words, here the angular momentum of the point mass, the angular momentum of the point mass is not a vector L vector. So the angular momentum of the point mass having a linear momentum is p vector. The same point mass, it has the angular momentum. The angular momentum of the point mass is having the linear momentum p. At the position is r. With respect to axis of rotation, axis of the point. Okay students, we consider one of the body. This body it has a fixed point O. At a point R there is also experience a momentum. That momentum is one of the angular momentum, that is L vector is equal to R into P vector. Okay, so the angular momentum is equal to perpendicular distance into linear momentum. So the magnitude of the angular momentum, it can be written as L is equal to R P sin theta. So suppose if the linear momentum, it is making the angle. If it is making the angle, we can write L is equal to R into P sin theta. Here the theta is the angle between R vector and P vector. R vector means there is a position. This is a position, and P vector means there is a momentum of the point mass. The momentum of the point mass is P vector. Okay, linear momentum. So the theta is the angle between the R vector and the P vector. So the L vector is perpendicular to the plane containing r vector and p vector. Here the L vector, the angular momentum is perpendicular to the plane containing p vector and r vector. Okay students, so this expression it can be written as L is equal to r into p sin theta. So from this we can write r into p is perpendicular. Okay, so what is the meaning for this? Here the linear momentum p vector is the component of the linear momentum. The p is perpendicular to r. P is perpendicular to r. Otherwise it can be written as L is equal to r sin theta into p. It can be written as r sin theta into p. So what is the meaning for this? This is r is perpendicular to p. Okay, in other words we can write this r position vector is perpendicular to the linear momentum. So by using this concept we can give various explanation for this expression. The angular momentum is 0. Angular momentum is 0. So first condition, the angular momentum is 0 means we can write if the linear momentum is 0. When p is 0, here it is with the values L is equal to 0. First. Next one, we can take the L is equal to 0 at the time the theta is equal to 0 degree or 180 degree. Okay, what is the meaning for this? The angle between the r and p. The angle between the r and p is 0. What is the meaning? It is in a straight line. The p is acting in the straight line means the angular momentum is 0. The angular momentum is 0. Otherwise, if it is opposite, that is 180 degree. The p is opposite to the r vector. So that is 180 degree. That time the angular momentum is 0. Okay. So next one is we can take that r vector and p vector. The r vector and p vector are parallel. Are anti-parallel. Okay, so r vector and p vector both are parallel or anti-parallel. Here the angular momentum is 0. So from this concept we can easily explain this. Here the angular momentum, it is a quantity that is associated only with the rotational motion is wrong. Okay, so here we consider that angular momentum is a quantity that is associated only with the rotational motion is one of the misconception. Okay, that is a misconception. That is a misconception. Okay, so here we consider the angular momentum is also associated with the bodies in linear momentum. Okay, in linear momentum. The angular momentum is in the linear momentum. So for understanding purpose, I am going to explain one example sum. A particle of mass m moving with velocity v. So show that the angular momentum about any point remains constant throughout the motion. So for this, we can take a point mass. It's execute a momentum, that is a linear momentum is p vector. Linear momentum is p vector. So this point mass, it has a velocity is v. Okay, it has a velocity is v. So it is execute a linear momentum, that is not a vector p vector. To explain the angular momentum is also associated with the bodies in the linear motion, we are taking this diagram. So to explain that concept, we are choosing the origin. The origin is O, is placed perpendicular to the linear motion, is placed perpendicular to the linear motion at the distance t. So from the origin, we take the point mass with the distance is r vector. That is a position. The position of the point mass is r vector. Here you noted the angle between the origin and the linear motion, that is noted by letter theta. Here we know the point is Q. At a point it is making the angle is theta. So by using this concept, we are taking the magnitude of the angular momentum. The magnitude of the angular momentum, it is making the angle is theta. So the magnitude of the angular momentum is calculated by using the formula of L is equal to, what is the values? Already you know, the L is equal to R into P. R means there is a position into P vector. That is a linear momentum. So by using this concept, we can write that position, that is R vector, it is also noted OQ. OQ into linear momentum is P. It is making the angle is theta, so we can write that is P sin theta. So L is equal to OQ. What is the meaning for P? P means that is a linear momentum. It has values as M into V. It is substituted in this equation means M into V sin theta. So from this we can write that values, the term OQ sin theta is perpendicular. The OQ sin theta is a perpendicular distance D between the origin and a line along the mass is moving. Hence, the angular momentum of the particle, it can be written as L is equal to the OQ sin theta, it is equal to perpendicular distance, that is equal to D. So we can write L is equal to M into V into D. Okay, so from the triangle you can calculate the values of the sin theta. So how we can take that values means, what is sin theta? Sin theta is equal to opposite side divided by hypotenuse. What is the hypotenuse? Hypotenuse is OQ. So we can write what is the values of D? D is equal to OQ sin theta. Okay, we consider this triangle and calculate the values of sin theta. Sin theta is equal to D divided by OQ. So we can write D is equal to OQ sin theta. So only we can write OQ sin theta, it can be written as D. So L is equal to M into V into D. So this is a linear motion. In this linear motion we calculate the values for the angular momentum. So the above expression for the angular momentum L does not have the angle theta. That does not have the angle theta. In this linear motion, if you are taking the values of theta means you can calculate the values of the angular momentum here. But in this linear motion, here the mass is moving in straight line, there is no angle theta. So it is executing a linear momentum, that is P is equal to M into V. It is also perpendicular distance D are constant. The angular momentum of the particle, it is also constant. The angular momentum is always constant. The angular momentum is always constant because here the mass is constant, the velocity is constant velocity. Okay, so it is moves in a straight line, there is no perpendicular distance. The perpendicular distance is always constant. It is moves in a straight line. If there is a perpendicular distance is increases or decreases means there is experiencing angular momentum. It is making the angle is theta. Okay friends, so the angular momentum is associated with the body with a linear motion also. If the straight path of the particle passes through the origin, then the angular momentum is zero. If it is traveling in a straight line means the angular momentum is zero. That one I told. If it is a parallel, the position is parallel to the momentum means it is the value is zero. The angular momentum is zero. Okay, so which is also constant value. So the angular momentum is also associated with a linear motion. Okay, so the angular momentum is only for the rotational motion is one of the misconception. It's one of the misconception. Okay.